Hello, we are now in the fourth quarter and we are going to discuss the lesson for the first week. For the first part of our lesson, we will be discussing about the real-life problems that can be solved by statistics. Before we start, let us have a short activity. So I will be showing you jumbled letters and you are going to unscramble them to form the words related to our lesson for today. Here is our first word. What word will be formed when we unscramble these letters? The answer is statistics. Number two. How about this? So we have four letters. And the answer is data. The next word is this. The first letter is T and the last letter is T. And the answer or the word is percent. Number 4. How about that? RENAG. Our fourth word is range. Did you get that? Very good. And for the fifth one, we have this jumbled letters. What word will be formed when we unscramble that? Your answer should be average. So that and other more terms will be discussed in our lesson for today. Okay, here is our most essential learning competency for lesson 1.1 and for lesson 1.2. So I'll give you some time to read them. Okay, so first let us define what is statistics. Statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. In other words, statistics is about using data to answer questions. In our daily activities, we encounter problems or questions that can be answered using statistics. By now, you should have an idea about what statistics is all about. Okay. In this illustration, you can see examples of statistical questions. I want you to observe them clearly, and then later on, we will define or describe what statistical questions are. Okay, for the first example, what are the activities of 7th graders during quarantine period? For the second question, how many people did the TikTok challenge? Number 3, what is the typical number of pets owned by students in your section? Number 4, who is the favorite math teacher of your classmates? And number 5, do shoppers in your barangay use paper bags or plastic bags? So those are examples of statistical questions. By now, you should have an observation or description about statistical questions. While you are thinking about that, here are examples of questions that are not statistical. The first question is, what's the name of our present president? Number 2, what time did you get up this morning? Number 3, how many pets do you have at home? Number 4, how many TikTok challenge did you do yesterday? And for the fifth question, do you like Jollibee? Can you see the difference between statistical questions and questions that are not statistical? That is correct. So statistical questions are those that need investigation by collecting set of data. Means that we have to investigate or conduct surveys for us to answer the question. And it has different answers. The answers could be in percent, range, or in average. Remember that. On the other hand, a question is not statistical, okay, not statistical if it has an exact answer, just like these examples. The exact answer for this is Rodrigo Duterte. Number 2, it depends. Okay, let's say 6 a.m. You woke up at 6 a.m. Number 3, you can just answer with numbers, right? So there is an exact an exact answer. But for this statistical questions, we have to ask people or we have to investigate before we can answer them. Okay, so that's the difference between the two. Okay, can you give other example of statistical questions? For that, I want you to type your answer in the comment section. Okay, and we will move on with the second part, which is the simple statistical instruments. These are what we use in order for us to collect data. First, let us define what is a statistical instrument. It says there, a statistical instrument is any process that aim at describing a phenomena by using any instrument or device. However, the result may be used as a control tool. That is the definition of statistical instrument. And there are some examples of statistical instruments such as survey and questionnaire. Let's go over them one by one. The first one is survey. I know you are already familiar with survey, but let us look at this definition. A survey is a process of gathering, sampling, analyzing, and interpreting data from a group of people. There are 4 types or 4 samples of survey. The first one is multiple choice. Multiple choice survey questions are questions that offer respondents a variety of different responses to choose from. These questions are usually accompanied by another option that the respondent can fill in with a customer answer if the option don't apply to them. Okay, so that is for multiple choice. You are given a series of choices and you are just going to select. Now, multiple choice survey questions has 2 classifications. The first one is single answer. Okay, from the word single, it means that you are only allowed to select one answer from the list of options. Okay, so even if you are given 10, 100 options, you just have to select one, only one answer. On the other hand, we have the multiple answer, multiple choice survey. Later on, I will show you that. But here is an example of a single answer multiple choice. This frequently appear online as circular button respondents can click. Okay, so this is circular and you can click if you like this, then you can select this. Okay, but if not, you can select the other options. But you just have to select only one. Here is the second type, which is the multiple answer. For multiple answer, it allows respondents to select all responses, okay, as many as they can that apply from a list of options. This frequently appear as checkboxes respondents can select. Okay, here is an example. Which of the following resources are available in your home for online learning? So if you have a phone, you have a tablet, you can select as many as you can, or you can select all of it. Okay, so that is for multiple answer, multiple choice. Now, that is the first one. Let's continue to number 2, which is a rating scale. A rating scale or rating scale questions, also known as ordinal questions, ask respondents to rate something on a numerical scale assigned to sentiment. From the word rate, you are going to rate. For example, how do you recommend the brand of your cell phone to your classmates? 1 being the worst and 5 being the best. Okay, so you're just going to rate. If it is worst, you select 1. But if it's best or you like your phone, you recommend it, so you select 5. Number 3, we have Likert scale. A Likert scale survey or Likert scale survey questions evaluate if a respondent agrees or disagrees with a question. Here is an example. How are you satisfied with the performance of your classmates' presentation? Are you happy or not very happy? So you just have to select if you agree or not, or if you are happy or not. Okay, so that is for Likert scale. And the fourth one, or fourth example of a survey is ranking. Ranking survey questions ask respondents to rank a variety of different answer options in terms of relative priority or importance to them. Ranking questions provide qualitative feedback about the pool of respondents, but they don't offer the why behind the respondent's choice. So no explanation, you just have to rank. For example, here's an example. Rank the following subjects in order of preference. 1 being your favorite and 8 being your least favorite. So if your favorite subject is math, you just have to rank it as 1, and then your next favorite, you rank it as 2, and so on. So that is for the example of ranking. And the other type of statistical instrument, or another statistical instrument that we can use, is the questionnaire. Okay, I know you are already familiar with the questionnaire. It is a series of questions that are asked to your respondents. It is simply one of the tools used to conduct a survey. Usually this is a printed copy, okay, and then there are a series of questions that the respondents have to answer. Here is an example. Okay, students' feedback questionnaire on lesson. For example, you are going to evaluate this lesson based on your teacher's performance. So you just have to select, is it always, or sometimes, or never? Okay, or often for O. So does the teacher explain things clearly? If it is always, you just have to select A. And there are a series of other questions that you have to accomplish. Okay, so that is an example of a questionnaire. To sum it all up, here are the different statistical instruments that we have discussed. So again, we have survey. Survey has 4 classifications. It can be a multiple choice, rating scale, Likert scale, or ranking. And then multiple choice can be classified as a single answer multiple choice or multiple answer multiple choice. And we have here a questionnaire, which is defined as another tool we use in conducting a survey. So this is just a tool. And remember, it has a series of questions that your respondents have to answer. So that's it. That's the end of our lesson for week 1. Our next lesson will be on the collection of statistical data. We will be discussing that next time. Thank you so much for listening. This is Mary Jane Palara. Thank you so much for listening. Bye. Hello, dear students. Today we are going to continue our lesson for the fourth quarter, week 2, which is on the collection of data. This is Mary Jane C. Palara, your math teacher. Before we discuss our next lesson, let us review your previous lesson. I will be showing you 10 questions and you are going to identify if they are statistical or not. If the question is statistical, you simply type S, but if it is not statistical, you type NS. Are you ready? Here are the questions. Question number 1, what is your favorite subject? Question number 2, what is your math teacher's name? 3, how many students in your school select the following: modular distance learning, blended learning, or online learning? Question number 4, what teaching style of your math teacher is more effective? Question number 5, do you like mango graham? Number 6, how many Filipinos are infected by the pandemic according to province? Question number 7, what is your father's name? 8, what is the most used connectivity of your classmates? Wi-Fi connection or mobile data? Question number 9, what is the brand of your cell phone? And question number 10, what is your favorite pizza toppings? I'll give you 5 more seconds to finalize your answers. And let us check. For question number 1, it is not a statistical question because it has an exact answer. Number 2 is also a not statistical question. Number 3, it is a statistical question because you have to conduct an interview or other ways of collecting data to answer the question. Number 4 is also a statistical question. Number 5, not a statistical question. Number 6 is a statistical question. Number 7 is not a statistical question. Number 8 is a statistical question. Number 9, not a statistical question. And the last one is also not a statistical question. How many did you get? If you got most of them, then very good. But if not, please review our previous lesson by watching our first video for the first quarter. Now let us begin with our lesson by defining what is data or data. A data is a collection of facts such as numbers, words, measurements, observations, or just descriptions of things. Now there are 2 types of data. The first one is the numerical data. This has, or every value of a numerical data is a set of numbers or is a number. For example, age, when we talk about age, so it talks about numbers. So we have 14, 12, your ages may range from those numbers. Okay, so it is a number. For letter B, height is also a numerical data because heights can be written as 5 feet, 6 feet, 7 feet, 8 feet, and so on. Another example is weight. So you may say that your weight is 59 kilograms 70 kilograms or 48 kilograms, and so on. The last example is general average. So if I ask you what is your general average for the fourth quarter or for the third quarter, so your answer could be 88, 89, 95, 92, or 86, or any number or any constant number. The other type of data is the categorical data. So this data set is a non-numerical or is non-numerical in value. For example, we have colors. So what are our colors? We have red, green, blue, and black. So we cannot identify colors based on numbers. Another one is labels. So it can be small, medium, large, extra large, and so on. Another example is cell phone brand. It can be iPhone, Samsung, Huawei, Oppo, or Vivo. And the last one is gender. It can be male or female. So those are the two types of data. This time, let us look into some of the techniques that we can use to gather statistical data. We are going to discuss 5. The first one is the interview method. The interview is a person-to-person encounter between person gathering data, who is called the interviewer, and the person supplying the data, who is called the interviewee. So there are two types of an interview method. We have the personal interview, which is a face-to-face question and answer method. Another one is the telephone interview. So it can, this question and answer method uses mobile phones or telephone. Okay, so you can see the difference between the two. If it says they're personal, you have to be together with the person you are interviewing. You are in one place. But if it is a telephone interview, you can use any media to gather the information from the person you are interviewing. So those are the two types of interview method. The second one, or before that, we had to take note that one of the major advantages of the interview method is that questions can be repeated, rephrased, or modified for better understanding. So it is not fixed for your interviewee to understand the question. You can rephrase the question so that they can supply a better answer. Now let's continue. The second technique that we can use to collect statistical data is the questionnaire method. Written questions utilized to obtain information, either mailed or hand-carried to the respondents. In this method, respondents feel time to formulate appropriate answers, unlike in interview method wherein the respondents feel pressured for the on-the-spot answers. So for example, the students are asked to answer the evaluation form to rate their teachers in different criteria. So that is an example of questionnaire method. The third one is the observation method. The data are gathered either individually or collectively by direct observations. Again, by direct observations. The person who gathers the data is called the investigator, while the person being observed is called the subject. This method is used by psychologists, sociologists, and psychiatrists. So for example, in the time of COVID-19 pandemic, researchers obtained data by observing behaviors of patients. From their observations, they can obtain data. For number 4, we can also use documents to search or to gather statistical data. The researchers make use of existing records or documents available in both private and government offices. So for example, in school, we can gather information from the guidance counselors who keeps anecdotal records. Another one for history, we can base our data on historical data. And for the population, we can ask for the record of birth rates from the municipal offices or other sources. So those are some examples or some ways of collecting data by using documents. So that is number 4. The fifth one is the method of experimentation. Data needed to answer questions or queries may be obtained through a series of experiments. Scientific researchers like physicists and chemists usually make use of this method. So for example, we have here a researcher who is conducting an experiment because he wants to try different fertilizers, or he wants to check which fertilizer can help to produce more rice. So those are just some of the statistical ways or methods for us to collect data. Again, let us have a recap of what we have discussed in this lesson. A data is a collection of facts such as numbers, words, measurements, observations, or just descriptions of things. Another thing that we have learned is the two types of data, the numerical data and categorical data. Now, there are also 5 ways in which we can collect data. The first one is through interview method, through questionnaire method, observation method, through the use of documents, or through the method of experimentation. Thank you so much for listening to our discussion for today. So following or our next lesson is on organizing data using frequency distribution table. Once again, this is Mary Jane C. Palara, your math teacher. Bye. Hello, dear students. Welcome back to our lesson for the fourth quarter. We will continue with lesson 3, which is on organizing data using frequency distribution table, or FDT. By the way, this is Mary Jane C. Palara, your math teacher. Before we start with the discussion, let me check if you can still recall our previous lesson on data collection. For our review, I want you to determine whether the given is a numerical data or a categorical data. If you think it is numerical, you just have to type ND in the comment section, or you may write it on your paper. On the other hand, if it is categorical data, you just have to write or type CD. I hope that the instruction is clear to you as I give you 10 seconds to do the activity. All right. So with that, I hope that you were able to recall what numerical data and categorical data is. Numerical data have numeric values. On the other hand, categorical data have non-numeric values. So for example, in number 1, height is a numerical data because height can be expressed as 1.67 meters or 152 centimeters, but as long as you can express it in numbers. On the other hand, number 2 is a categorical data because our colors cannot be expressed as numbers. Colors can be red, orange, yellow, green, and so on. Number 3 is a numerical data because age can be expressed as 11, 12, 20, 50, and so on. Number 4, cell phone brand is also a categorical data because we cannot express it as numbers. So cell phone brands can either be Apple, Oppo, Samsung, and so on. Number 5, salary is a numerical data because salaries are expressed as numbers. So I hope that you got 5 over 5 in that review. So as a continuation of our lesson, it says there, after a sample has been chosen and data were collected, the data obtained is actually unorganized. Before we can draw conclusions from them, it must be first summarized and represented in a way that it is easy to visualize and understand. That's why we are having this topic today on frequency distribution table, because it is a way of organizing the data that we have gathered. First, we have here a question. What is a frequency table? Let us first define the word frequency. The frequency of a particular data value is the number of times the data value occurs. For example, the following is a list of shoe sizes of 35 boys. Here is the list. Now, as you can see in the list of shoe sizes, those boys who have a shoe size of 2 are only 2. It means that only 2 boys have a shoe size of 2 based on the list given. So that is the frequency of shoe size 2. Next, 7. Let us count how many 7s are there. So we have 1, 2, and 3. It means that the frequency of shoe size 7 is 3. And for the last one, how about the frequency of shoe size 4? So let us count 1, 2, 3, 4, 5, 6, 7, 8, and 9. That means that 9 is the frequency of 4 because it appeared 9 times in our list. I hope that with that you were able to understand what is frequency. This time, let us define frequency table as a whole. A frequency table is a table that lists items and uses tally marks to record and show the number of times data values, and it is composed of 3 columns. Again, it is a table that lists items and uses tally marks to record and show the number of times data values appear, and it is composed of 3 columns. So here are the 3 columns. The first column shows the class interval, the second column shows the tally, and the last column or the third column shows the frequency. So those are the 3 parts: class interval, tally, and frequency. So this time, let us learn how to organize data using frequency table. A frequency table is constructed by arranging collected data values in ascending order of magnitude with their corresponding frequencies. The data values are then grouped in intervals, for example, from 0 to 5, 5 to 10, and so on. Following a rule for boundary values, frequency counts are noted for each interval. In this example, the intervals are 1 to 3, 4 to 6, 7 to 9, and 10 to 12. So let us try to construct a frequency table using this data. for step 1, in the first column, we write down the class intervals given. So in this case, the class intervals are 1 to 3, 4 to 6, 7 to 9, and 10 to 12. This time, let's continue to step 2. For step 2, in the second column from the given list above, we count the number of observations falling within each class interval and put strokes. Here is our table. So our first column is complete with the class intervals on it. So 1 to 3, 4 to 6, 7 to 9, and 10 to 12. All we have to do now is to tally. So to tally, we just have to look at the data and then put a stroke on the interval it belongs to. In this example, 7, our first data is 7. It falls in the class interval 7 to 9, so we put 1 stroke. 10 falls in the class interval 10 to 12, so that is another 1 stroke for that interval. 4, 4, 6, 5, and 4 all falls in the class interval 4 to 6. So that is 1, 2, 3, 4, 5 strokes. 1, 2, 3, 4, and 5. Let's continue with the second line. So 8 here falls in the class interval 7 to 9, so that is 1 stroke. 5, 5, and 4 all belongs to the class interval 4 to 6, so that is 3 marks. 1, 2, 3. Next, 3 falls under or belongs to the class interval 1 to 3, so that is 1 stroke. And then 10, we have 1 stroke for 10 to 12. 6 belongs here, and then 5 also belongs to that interval, and so on. So you continue doing that, and when you do that, we will have this result. When we are finished putting strokes in each class interval, so this is the result. Okay, so that is how it looks like for the tally. We can now proceed to step 3. For step 3, after tallying, we count the tally marks in each row and put the number in the last column. This is now called the frequency table. So what we have to do is to just find the total of the tally marks. For this, for the class interval 1 to 3, that has a total of 5, so we write 5. For the class interval 4 to 6, that is 5, 10, 15, 20, and 21. So we write there in the frequency 21. 7 to 9 has 6 tally marks, so we put there 6. And then for 10 to 12, it has 3. Frequency of 3. So that is our frequency table. Once again, here is our frequency distribution table. So we just put there the total. When we add all of the frequency, 5 plus 21 plus 6 plus 3, the total is 35. And we now have our frequency table for the list of shoe sizes of the 35 boys. Note, we have here a note that the total number of frequencies is the total number of data given. So 35, if for instance you are answering a problem or I asked you to construct a frequency table and the total does not sum up to the number of data, it means that you are missing or you missed some data, or you did not include it in your tallying. So you have to recheck and uh, construct your table. Here is example number 2. For example number 2, we have here the scores of 30 students in a math quiz. We have 86, 83, and so on. So there are 30 scores since there are 30 students. The class interval is already given. So we have from 71 to 75, 76 to 80, 81 to 85, 86 to 90, 91 to 95, and 96 to 100. The class interval is already there. So we are done with column 1. You just have to tally the scores, or yes, the scores. So 86, let's mark where does 86 fall. It falls under this class interval. So we put 1 mark. 83 is between 81 to 85. 81 belongs to the interval 81 to 85. The same with this one. And then 80 belongs to this interval. 87 belongs to the class interval 86 to 90. 94 belongs to the interval 91 to 95. 91 also belongs to that interval. 82 belongs to the interval 81 to 85. 76 belongs to the interval 76 to 80. 87 belongs to this 87 belongs to the interval 86 to 90, and then 80 belongs to this interval 72 in this interval. And after we are done with that, we will have this result. After tallying all the scores, so this is the result. We can now proceed to step 3, which is counting the frequency for each interval. For the class interval 71 to 75, the frequency is 4. For 76 to 80, that is also 4. For 81 to 85, the frequency is 12. 86 to 90, the frequency is 6. 91 to 95, the frequency is 3. And 96 to 100, the frequency is 1. And the total, when we add all of those, is 30. So that is equal to the number of data that we have gathered. It means that it is complete. So this is our frequency table for example number 2. I hope that you were able to follow with our examples. Let us just have a quick recall of what we have learned. A frequency table is a table that lists items and uses tally marks to record and show the number of times data values appear, and it is composed of 3 columns. There are steps that we follow in constructing a frequency distribution table. Step 1. In the first column, we write down the class intervals given. For step 2, in the second column, from the given list, we count the number of observations falling within each class interval and put strokes on it. For step 3, after we tally, we count the tally marks in each row and put the number in the last column. We are now done with our frequency table. With that, I want to invite you to watch our next video, which is on types of graph. So that is the coverage for quarter 4, lesson 4. Thank you so much for listening. Once again, this is teacher Mary Jane C. Palara. Until next time, bye. Hello, Math 7 learners. Today we will continue with our lesson for the fourth quarter, which is on the types of graph. By the way, this is Teacher Mary Jane, your math teacher. First, let us look at the definition of graph. A graph is a visual representation of a set of values in relation to another set. It is used to present data being presented in tabular form. It is also defined by Merriam-Webster Dictionary as a diagram that represents the variation of a variable in comparison with that of one or more other variables. The important features of a graph are the title of the graph and the two elements or variables that are being analyzed. In our lesson for today, we are going to learn about 5 types of graph. The first one is the pie chart. The second one is the bar graph. The third one is the line graph. The fourth one is the histogram, and the fifth one is the ogive. So let us look at each of those graphs. The first one is the pie chart. It is represented by a circle divided into parts. It also shows the relationship among parts, as well as the relationship of a part to the whole. The data are presented in percentage form and represented in the circle graph by an equivalent fractional part of a whole. In this diagram, you can see an example of a pie chart. This pie chart has different parts: the title, the labels, and the legend. These parts are important for us to easily analyze and to give descriptions to the data presented. Now, how do we construct a circle graph? It says there, to construct a circle graph, let us recall the lessons on measure of central angles. In the example below, the percent rate for each chosen ice cream flavor is given. The rate is multiplied by 360 degrees. Why 360 degrees? Because it is the measure of one full circle. It means that we are going to divide the whole circle into parts depending on the percentage. For example, for mango, since it is 20%, so we are going to multiply 20% times 360. In the next column, you will see 20% was written as a decimal. So for us to multiply a percent by a number, we have to first change it into decimal. The equivalent of 20% is 0.20. Multiplying it by 360 degrees, the result is 72 degrees. The second flavor is Rocky Road, and it is 40%. Again, 40% is equivalent to 0.40, and when we multiply it by 360 degrees, the result is 144. We do that with the other flavors, ube, mocha, and tinapa. And if we get the total of that, it must be equal to 360 degrees. Given that data, we can now use a protractor to determine the measure of each sector of the circle representing each item in terms of degrees. So in our answer a while ago, mango is 20%. So that is the 20% of 360 degrees is 72 degrees. It means that this angle measures 72 degrees. The same for the others. For the Rocky Road is 40%, multiplying it by 360. Our result a while ago is 144. It means that this angle measures 144 degrees. And as I have said a while ago, the total measure of these angles is 360 degrees. Now, if you want to analyze the graph, we can continue by determining the number of students who chose a particular flavor of ice cream. When we are given the total number of students, we can easily do that. For instance, the total number of students is 60. So we simply multiply the percentage by the total number of students. Here is the result when we do that. For mango, let's say, for example, 20% of students like mango, and there are a total of 60 students. So 20% of 60 is equal to 12. It means that during the gathering of data, 12 students chose mango flavor. For Rocky Road, 40% of 60 is 24. That means that 24 students chose Rocky Road. For Ube, there were 15 students. For Mocha, there were 6 students. And for Tinapa flavor, there were 3 students who chose it. Let's look at another example of a pie chart. So the title of this pie chart is A College Student's Budget. A college student has totaled his expenses for the last school year and represented his findings in a circle graph. Here is the result. Now, I want you to observe the graph as we answer the questions that follow. For question number 1, which 2 items account for the greatest expenses? Of course, the answer there is the house rent and food. House rent is 30% of the budget and food is 20%. For number 2, what percent of the budget is spent for food? And the answer is 20%, as you can see in this label. Question number 3, what percent of the budget is saved? So we look at the savings, which is 2%. Number 4, which 2 items incur the same expenses? And the answer to that is tuition fee or books and cell phone load, because they are both 15% of the budget. Next question. If the yearly allowance amounts to 150,000 pesos, how much is spent for each item? So for us to do that, we simply multiply the percentage for each item by the total amount, which is 150,000. When we do that, here is the result. House rent is 30%, food 20%, tuition fee or books 15%, clothing 10%, cell phone load 15%, utilities 8%, and savings 2%. They were all multiplied by 150,000, and here are the results. As you can see, house rent gets most of the budget is spent for house rent, which is 45,000. So that is the importance of graphs. We can easily identify data, or we can easily present data using graphs. The second type of graph is the bar graph. A bar graph is used for making direct visual comparison of data. The bars in the graph may be drawn horizontally or vertically to present or to represent the information. Here is an example of bar graph with its parts. We have the title. Once again, the title is very important because it is a way for us to determine what the graph is all about. We also have the bars. So in this example, these bars are drawn horizontally. I mean vertically. Then we also have the categories, and then our scale from 0 to 8, and then the x-axis label, which is the favorite color, y-axis label, which is the number of students. So those are the different parts of a graph. Here is an example. The data on the charity donations of each grade level in a high school is shown in a graph or in a bar graph below. Once again, I want you to study the graph and observe the information given as we answer the following questions. For question number 1, what information does the graph provide for you as the reader? That question pertains to the title of the graph, which is the charity donations of each grade level. Number 2, give an approximation for the charity donations of each grade level. So let's look at the graph. By the way, this is an example of a horizontal bar graph. For grade 7, it is approximately 21,000 pesos because it exceeded 20,000. This line is 20,000. It exceeded a little, so let's add a little. So it's 21,000 approximately. For grade 8, it is exactly on this line. So it is exactly 25,000 pesos. For grade 9, it is 30,000. And for the grade 10 students, the total donations is 40,000 pesos. For grade 11, it is 15,000. And for the grade 12 students, it passed through 20,000 more than that of the grade 7. So let's add another 1,000. So that is 22,000 approximately. For question number 3, how do the two largest charity donations compare? Approximately how many thousands do they differ? As we can see in the graph, the two largest donations are from the grade 9 and grade 10, which is 30,000 pesos and 40,000 consecutively. Okay, but the question is about their difference. So we simply subtract the two. 40,000 minus 30,000 is equal to 10,000 pesos. So that is the difference between the two largest charity donations. Question number 4, which grade level has the greatest charity donations? Obviously, it is the grade 10 students who gave a total of 40,000 pesos. Let us look in this another example of bar graph. The bars in a bar graph can also be drawn vertically. Presented below is a multiple vertical bar graph. And let us analyze that graph as we answer the questions that follow. For question number 1, says there, what does the graph tell you? It means that it is asking about the title. Our title is the SIM card used by students per grade level. Number 2, what does each type of bar represent? So each bar represents the different types of SIM card. So for green, it is globe. For the brown, lighter brown, it's smart. Darker brown, talk and text. Gray for sun cellular. And then the bar with a red border is for non-subscribers. Question number 3, which kind of SIM card has the greatest number of student subscriber? We can easily determine that by looking at the graph. So here, this SIM card gets the most subscriber, and that is the color for smart. So if we can say that most of the students are subscribed or uses the smart SIM card. Question number 4, what kind of SIM card has the least number of student subscriber? Well, looking at our graph for the grade 7, it is this SIM. For grade 8, there's none. Okay, so obviously it is the gray SIM card, and the gray SIM card, basing on the legend, is Sun Cellular. Means that the students or the list, the SIM card which has the least number of subscribers is Sun Cellular. Question number 5, which grade level has the greatest number of non-subscriber students? And based on our graph, it is this grade level, okay, and that is grade 12. It means that the answer to question number 5 is grade 12. The third type of graph is the line graph. A line graph is used to show changes between two quantitative data. Usually, one of the quantities under consideration is time. Once again, usually we use a line graph to show changes over time. The relation between these two is graphed on a rectangular coordinate plane. The quantity time is usually plotted along the vertical axis. Points are plotted based on the relationship of the quantities and those points reconnected by a line. Here is an example of a line graph with its parts. So here is the title, and then we have the label for the horizontal axis or the x-axis, the label for the vertical axis or the y-axis, and then we have here the scale. The next one are the points here, which are connected by line segments. Let's look at the first example. Once again, we will answer some questions based on this graph. Question number 1, what two quantities are being considered in the line graph? This question is simply asking about the labels of the x-axis and the y-axis. So for the x-axis or the horizontal axis, these are the months, and for the y-axis, it is the electric consumption in kilowatt hours. So those are the two quantities being compared or being considered in our graph. Question number 2, when did the highest consumption occur? So let's answer that first. And the peak is in this month, which is in the month of May. So the answer to that first question is May. On the other hand, the lowest consumption is in this month, which is in the month of November. Question number 3, which month show the same amount of consumption? So let's look at our graph, and we can see that this month and this month shows or have the same consumption. So it is the month of March and July. So our answer is March and July. Question number 4, between which two months was the greatest increase or decrease in consumption greatest? First, let us answer the greatest increase. The answer is from this month to this month. So you can see it is a very long line going upwards. So the greatest increase is from November to December. On the other hand, the greatest decrease is from this month to this month, which is from October to November. Here is example number 2. Once again, let us analyze that as we answer the questions. Number 1, what are being compared in the multiple line graph? Once again, for the y-axis or for the x-axis or horizontal axis, we have the year, And then for the y-axis or vertical axis, we have the production in 1,000 metric tons. So those are the two variables we are considering in this graph. Question number 2, what does the vertical axis represent? The horizontal axis. So same answer to that of number 1. Okay, we just label vertical axis focuses in the production of crops. Horizontal axis is on years. Question number 3. What was the approximate production for each crop in the beginning year? Our beginning year is in 2015. So let's start one by one. Our products are the following. Kamote. Approximately it is between 0 and 20, so that is approximately 10,000 metric tons. Turnips is in this line, so it is exactly 20,000 metric tons. For onions, it is the same, it is in this line, so it is also 20,000 metric tons. For corn, it is here, it is aligned in 40, so it is 40,000 metric tons. And for palay, it is between 40 and 60, but it is higher than the half, so we can approximate it as 55,000 metric tons. Okay, for question number 4, which two crops followed almost the same trend of increase in production for several years? So we simply look at the graph and we can see that the red line and the dark orange brown follows the same pattern, and those two are represented by palay and corn. It means that the answer to question number 4 is palay and. Question number 5. In what year was the production of palay, corn, onions, turnips, and kamote the greatest? Let's answer that first. So kamote, for kamote, the greatest production is in this year, that is 2017, and also in this year. So that should be 2017 and 2020. For the next crop, for turnips, it is in this year, so that is 2020. For onions, it is also 2020. Same with corn and palay. The kamote crop, and for the next question, it says there, which crop showed a very slight increase? And the answer there is the kamote crop, because it showed a very slight increase from 10 to 24. That is the answer to our last question. The fourth type of graph is the histogram. The histogram is a graphical display of data using bars of different heights. It is similar to a bar chart. Remember, it is similar to a bar chart, but a histogram groups numbers into ranges and shows no gaps between the bars. The height of each bars shows how many falls into each range, or simply the frequency. The histogram is constructed as a sequence of vertical rectangles. Each rectangle is drawn with its base equal to the class interval and a height corresponding to the class frequency. Here is an example of a histogram. Once again, it is similar to a bar graph, but a histogram has no gaps. It means it is continuous because it represents a continuous set of data. So we have here the title, we have here the intervals for the x-axis, the intervals for the days of operation, in the label, and then the frequency is in the y-axis. Here is another example of a histogram. Let us look into each part of the histogram. So the title, the title describes the information included in the histogram. The x-axis or the horizontal axis are intervals that show the scale of values which the measurements fall under. For y-axis, the y-axis shows the number of times that the values occurred within the interval set by the x-axis. And of course, the bars, the height of the bar shows the number of times that the values occurred within the interval, while the width of the bar shows the interval that is covered. Again, here is, for example, in this graph. So for the first bar, it means that the number of respondents or number of teachers that belongs to this range, that is from 1 to 3, is 2. Since the frequency is 2, the number of students that fall in this scale is 2. For this scale, it is 4. For this, it is 8, and so on. Now, why are histograms important? So creating a histogram provides a visual representation of data distribution. It is used to summarize discrete or continuous data. Histograms can display a large amount of data and the frequency of the data values. It provides a visual interpretation of numerical data by showing a number of data points that fall within a specified range of values called bins. Those are the importance of a histogram. And there are different distributions of a histogram. The first one is a normal distribution. In a normal distribution, points on one side of the average are as likely to occur as on the other side of the average. So, as you can see here, it is low in this part, same in this part, and then the peak is in the center. Okay, so that is a normal distribution of a histogram. Now, here is another one. We have a bimodal distribution. A bimodal distribution, in a bimodal distribution, there are two peaks. So here is an example. Here is the first peak, and then here is the second peak. In a bimodal distribution, the data should be separated and analyzed as separate normal distributions. So for instance, you have this type of a histogram, so you should divide it and analyze each of this as separate or as a separate normal distribution. The third one is a right skew distribution. Here is the diagram for it. A right skew distribution is also called a positively skewed distribution. In a right skew distribution, a large number of data values occur on the left side, with a fewer number of data values on the right side. So it means that most of the respondents or most of the data falls under the range on the left side. That's why it's called a right skew distribution. A right skew distribution usually occurs when the data has a range boundary on the left-hand side of the histogram. For example, a boundary of 0. The opposite of a right skew distribution is a left skew distribution. Here is the illustration. A left skew distribution is also called a negatively skewed distribution. In a left skew distribution, a large number of data values occur on the right side, with a fewer number of data values on the left side. A left skew distribution usually occurs when the data has a range boundary on the right-hand side of the histogram. For example, a boundary such as 100. So this is an example of a left skewed distribution. And the fifth type of graph is the ogive. The ogive, or an ogive, sometimes called a cumulative frequency polygon, is a type of frequency that shows cumulative frequencies. In other words, the cumulative percent are added on the graph from left to right. An ogive graph plots cumulative frequency on the y-axis and class boundaries along the x-axis. It's very similar to a histogram, only instead of rectangles, an ogive has a single point marking where the top right of the rectangle would be. So they are similar. An ogive is similar with that of a histogram. The only difference is that the histogram shows or uses rectangles, and for ogive it uses points. Here is an example of an ogive. You might mistook it for a line graph, but if you will see the label of the x-axis, you will see that it has a range. So 1 to 9, it means that it is a continuous data. That's why it represents a cumulative frequency. Okay, so 10 to 19 and so on. That is the difference between an ogive and a line graph as well. Okay, so there are class boundaries or ranges on the x-axis. We have here an example. It says there, draw an ogive graph for the following set of data. And when we draw a table for that, we have here the class boundaries. The frequencies are the following. And then the cumulative frequency are as follows. And when we get the percentage, it is as follows in the fourth column. Given that, we can use the Microsoft Excel to input the data, and here is the result for our ogive graph. We can be discussing more on this for higher mathematics. Okay, so as long as you know the difference between the different types of graph, then we are good to go. Let us recall. Today we have learned about the different types of graph, the pie chart, which shows the relationship among parts as well as the relationship of a part to the whole. The bar graph, which is used for making direct visual comparison of data. The line graph, which is used to show changes between two quantitative data and usually involves time. Histogram, it is similar to a bar chart, but a histogram groups numbers into ranges and shows no gaps between the bars. The fifth one is an ogive, which is sometimes called the cumulative frequency polygon, which is a type of graph that shows cumulative frequency. Thank you so much for listening to our discussion for today. Our next lesson will be on the measures of central tendency involving ungrouped data. Thank you and goodbye. Hello, Math 7 learners. Today we are going to learn about the measures of central tendency of ungrouped data. By the way, this is teacher Mary J. The following are our most essential learning competencies, and our reference is also stated. First, let us define what is central tendency. It is a score that is typical of the distribution of scores, the score that may represent the totality of the distribution. The following are the measures of central tendency. Each has its own applicability depending upon the characteristics of the distribution or the type of scale used. The first one is mean, or the arithmetic average of a set of scores. Once again, average. The second one is median, the score that divides the set of scores into two equal halves. The next one is the mode, which refers to the most frequent occurring score in a set of scores. Take note of those three as we solve for mean, median, and mode of ungroup data. Let us start with the arithmetic mean. In solving for arithmetic mean, we use the formula x bar is equal to the summation of x over n. Again, this is summation. This is a symbol for summation. It means the total number of scores or the total of the data given. N stands for the number of given data. Let us have example number 1. It says there, compute the mean of the following scores. The scores are as follows: 90, 86, 78, 88, 78, 89, 90, 95, 93, and 86. There are steps that we can follow to solve for arithmetic mean. So the first step is for us to find the sum of all the scores or data, or the symbol, the summation of x. To do that, we simply add each of the scores. So we have 90 plus 86 and so on until the last score, which is 86. When we add all of those, the total is 873. For step 2, we divide the sum that we've got in step 1 by the number of given data or scores, which is n. And here is 10 because there are 10 scores in the given. We substitute to our formula. So the mean for arithmetic mean is 873 divided by 10. We simply divide the result from step 1 and step 2, and the result is 87.3. It means that the average or arithmetic mean of the given data is 87.3. That ends the solution for example number 1. Here is example number 2. A group of students obtained the following scores in a mathematics quiz: 8, 7, 9, 10, 8, 6, 5, 4, and 3. We will find the mean score of the students. We again follow the steps. For step 1, we find the sum of all the scores. So 8 plus 7 plus 9 plus 10 plus 8 plus 6 plus 5 plus 4 plus 6 is equal to 63. For step 2, we divide it by n. N, or the total number of scores in our data, is 9. There are 9 students. So when we divide 63 divided by 9, the result is 7. Means that 7 is the average score of the students. Example 3. The age of the service crews in a restaurant are as follows: 19, 21, 20, 47, 18, 18, and 18. We have to find the mean age. For step 1, we have to again find the sum of all the ages. The sum is 161. Step 2, we divide it by n. In the given, there are 7 service crews, so our N is 7. And substituting the result in step 1 and step 2 to our formula, we have 161 divided by 7. And the result is 23.86. So it means that the average age of the service crews is 23.86. The second measure of central tendency is the median. Here are the steps in finding the median. First, we arrange the scores from lowest to highest, and then after that, we get the middlemost score. Take note that if the number of scores is odd or is an odd number, we have to get, or we simply get the middlemost score. However, if the number of scores is even, we have to find the average of those two, or of the two middlemost numbers. Let's look at the examples. Example 4, find the median of the scores below. For step 1, we arrange the scores from lowest to highest. And when we do that, here is the result. So we have 78, 78, 86, 86, 88, 89, 90, 90, 93, 95. Step 2, we get the middlemost score. But there are two scores in the middle, which is 88 and 89. So we have to get its average. So we first get the sum, which is 177 divided by 2. It is equal to 88.5. So the result, or the median for example 4, is 88.5. Here is another example. A group of students obtained the following scores in a mathematics quiz. Find the median score of the students. Again, we have to arrange the scores from lowest to highest. When we do that, the result is this. So the lowest score is 3, followed by 4, 5, 6, 7, 8, 8, 9, and 10. Step 2, we get the middlemost score. The middlemost score is 7, which makes the median 7. So 7 is the median score of the students in example number 5. Example 6. The age of the service crews in a restaurant are as follows. We have to find the median. Again, for step 1, we arrange the scores from lowest to highest. And here is the result. We have 18, 18, 18, 19, 20, 21, 47. Step 2, we get the middlemost score or number, and it is 19. It means that the median of the data given is 19. So that is how simple it is, or how easy it is to get the median of an ungrouped data. The third measure of central tendency is the mode. The mode is the most common score or the most frequently occurring value in a given set of data. So there are different types: unimodal if the data has only one mode, bimodal if it has two modes, and multimodal if it has more than two modes. It is also possible that a data has no mode. Let us look at the following examples. Example 7, find the mode of the following set of scores. So the scores are as follows: 78, 75, 80, 75, 89, 75, 90, 95, 83, and 75. So which among those scores appeared most frequently? The answer is 75, because 75 appeared 4 times. So the mode for example 7 is 75. Next, so since it has only one mode, so the type of mode is unimodal. Example 8, find the mode of the scores below. Here are the scores, and in this case it has three modes, which is 78, 86, and 90. Why? Because 78 appeared twice, 86 appeared twice, and 90 also appeared twice. This is an example of a data which is multimodal because it has more than two modes. And for example 8 or example 9, we have to find the mode of the scores below. We have 19, 21, 20, 17, and 18. As you can see, each of the scores appeared only once, which means that this data has no mode. So those are the examples for mode. Once again, thank you so much for listening to our discussion for this time. The continuation of our lesson will be on the measures of central tendency, this time involving group data. Until next time, bye. Hello students. Today we are going to continue with our lesson on measures of central tendency, this time involving group data. Here are our most essential learning competencies and our reference. Let's start off with the mean of group data. Here are the steps that we are going to follow in solving for the mean of a group data. For step 1, we determine the class mark, which we will represent with capital X of each interval or class interval by finding the midpoint of the upper limit and lower limit. Step 2, we find the product of the frequency or small f and the class mark, again capital X, in each class interval. We put the answer in the column for f times x, then get the sum of their products, which can be written as the summation of f times x. And lastly, for step 3, we substitute the needed values in the formula to find the mean. Here is our formula. X bar for mean is equal to the total sum of the product of f and the class mark x over n. We have here example number 1. Given the frequency table below, we compute for the mean. As you can see, we have 3 columns. So for the first column, we have the class interval. For the second column, we have the frequencies. So actually, these are the two given in our example. And under class interval, we have 90 to 94 as the highest, followed by 85 to 89, 80 to 84, 75 to 79, and 70 to 74 with their corresponding frequencies. And the total of all of it is represented by capital N, which is equal to 50. Now we have added another column for X, which we use for, or which we use to represent class mark. So how do we solve for class mark? We simply get the midpoint of our upper limit and lower limit. So for this, for the highest interval, 90 to 94, for us to get the class mark X, we simply add 90 and 94, as you can see in the solution. So 90 plus 94 is equal to 184 divided by 2, and the result is 92. That is why it is written there, 92. Moving on, the next interval is 85 to 89. Our lower limit is 85 and our upper limit is 89. Once again, we add the two. 85 plus 89 is equal to 174 divided by 2, and the result is 87. So we can write there 87. The next interval is 80 to 84. 80 plus 84 is 164 divided by 2 is equal to 82. So we type it under X. Next interval, 75 to 79. 75 plus 79 is equal to 154 divided by 2, and the result is 77. So that is the class mark for the fourth interval. And lastly, for 70 to 74, the sum is 144 divided by 2. So the class mark is 72. The next step that we will do is to find the product of the frequency and the class mark for each interval. We have to add another column, which we will write as f times x. Okay, so f for frequency and then x for class mark. Let's start with the product of 7 times 92, or 7 and 92. 7 times 92 is equal to 644. The next pair is 13 times 87. The result is 1131. For the next interval, we have 16 times 82. 16 times 82 is 1312. Next, 8 times 77 is equal to 616. And for the last interval, the product of 6 and 72 is 432. After multiplying our frequencies and class marks, we get the sum of all the products. And when we do that, when we add all of these numbers or all of these products, the result is 4,135. We already have our necessary data, which we will substitute in our formula. So we have here the value of the sum of f times x and the value of n. All we have to do is substitute. So we will have the mean is equal to 4,135 divided by 50, and the quotient of those two numbers is 82.7, or 82 and 7/10. That is the mean of our data. Let's move on to example number 2. We calculate the average daily income of Cocovidia's online selling business for 40 days. Here is our given. Again, for step 1, we determine the class mark or capital X of each interval by finding the midpoint of the upper limit and lower limit. We add another column for that. The first interval was already solved. We have obtained 1176 by getting the average of our lower limit 1172 and our upper limit 1180. For the next interval, 1163 plus 1171 divided by 2 is equal to 1167, followed by 1158, and then 1149. The next interval, for the class mark of the next interval, is 1140, followed by 1131, and then 1122. For step 2, we find the product of the frequency and the class mark in each class interval. Again, we have to add another column for that. We write f times x, and then we multiply the frequencies and class marks for each interval. 3 times 1176 is 3528. 5 times 100, or 5 times 1167 is equal to 5835. 9 times 1158 is equal to 10,422. The next interval, we multiply 12 by 1149, and the result is 13,788. Next, 5 times 1140 is equal to 5,700. And then 4 times 1131 is equal to 4,524. And the last pair, 2 times 1122 is equal to 2,244. After multiplying each pair, we get all of the sum, or the sum of all the products. So 3,528 plus 5,835 plus this number until this number, the sum is 46,041. Now we have obtained the value of the sum of f times x, and the value of n is already given, which is 40. So what we have to do is substitute those results to our formula. So the mean, or x bar, is equal to, let's substitute the value. For our numerator, we have 46,041, and for our denominator, we write 40. When we divide those two, we obtain the quotient, which is 1,151.025, or we can read it as 1,151 and 25 thousandths. Now we move on to the second measure of central tendency, which is the median. Again, we follow steps in solving for the median of group data. Before that, let us recall how to get the median of an ungrouped data. Can you still recall? Okay, for us to identify the median of an ungrouped data, we simply arrange the data in increasing or decreasing order, then identify the middle number, and that will be, the middle number is the median. However, if there are two middle numbers, or two numbers in the middle, we get the average of those two numbers, and the result is the median. Okay. Now for group data, there are 6 steps that we have to follow. Step 1, we determine the median class by dividing the total number of observations into 2. So we have the formula, median class is equal to n over 2. For step 2, we find the exact lower limit or lower boundary, which we represent using capital L for each class intervals. Step 3, we get a column for the cumulative frequency. We use capital F to represent this. Step 4, locate the median class in which the median lies and identify the frequency and lower limit. Step 5, we find the cumulative frequency of the median class. It is the cumulative frequency which is close to n over 2 but not exceeding it. And step 6, we determine the value of the median by substituting the values that we have identified from steps 1, 2, 3, 4, and 5 to our formula. So the formula is this: MD, or median, is equal to L, or the lower boundary, plus n over 2 minus F, or the cumulative frequency, over F, the frequency, and that, the quantity, we multiply it by the value of I, or the interval. Let's have an example. Example 3. Find the median score of students in 2 Mathematics 7 classes of Miss Vidya in the given frequency distribution table. We have here how many intervals? 1, 2, 3, 4, 5, 6, 7, 8 intervals. We already have the value of I, which is 5, and then the value of n, which is 100. So the total of all the frequencies is 100. So let us follow all of the steps. For step 1, we have to determine the median class. We simply divide n by 2. N divided by 2 is equal to 50. Step 2, we find the exact lower limit or lower boundary for each class interval. How do we do that? We get the average of the lower limit of the first or the upper interval, and then the upper limit of the lower interval, or it says there, the exact lower limit of each class interval is the midpoint of the lower limit of each class interval and the upper limit of the class interval below it. In this case, we will get the average of these two, or the midpoint. So 95 plus 94 divided by 2 is equal to 94.5. And that is the lower boundary or exact lower limit for this interval. For the next interval, again, we get the midpoint of 90 and 89. The result is 89.5. Doing the same process, the next lower boundary is 84.5, followed by 79.5, 74.5, 69.5, 64.5, and for the lowest interval, the lower boundary is 59.5. So we are done with step 2. We move on to step 3. It says there, get the column for the cumulative frequency, represented by capital F. Note that the cumulative frequency of the highest class interval is equal to the total number of items n. And to get the cumulative frequency of the succeeding class interval, we simply subtract the corresponding frequency from f of the prior class interval. Okay. With that instruction, so we start with the value of n, which is 100. The cumulative frequency of this interval, the highest interval, is 100. After that, we subtract the frequency, 5. 100 minus 5 is equal to 95. That will be the cumulative frequency of the next interval. And then we do the same process, subtract 95, or subtract the frequency 11 from 95. So 95 minus 11 is equal to 84. Same process, 84 minus 17 is equal to 67. And then 67 minus 25 is equal to 42. 42 minus 20 is equal to 22. 22 minus 12 is equal to 10. And 10 minus 7 is equal to 3. You can observe, or you can see, that the value of the cumulative frequency in the lowest interval is the same with that of the frequency of the lowest interval. So if that will always be the case whenever you solve for the median of group data. So in case the number here or the number you've obtained in the lowest interval or the cumulative frequency is not equal to that, it means that you have made a mistake in subtracting or in getting the other cumulative frequencies. We can now move on to step 4. For step 4, we locate the median class in which the median lies, and then identify the frequency and lower limit. Remember, our median class is 50. So 50 is located in this interval. It belongs to this interval. Having our clue is that we have here the cumulative frequency, which is higher than 50. It is 67. So we consider this interval. That is where we will obtain the value of F and the value of L. Okay. The value of our frequency is 25, and the lower boundary or exact lower limit is 79.5. And then for step 5, we find the cumulative frequency of the median class. As we have read a while ago, this or the value of F is close to n over 2 but not exceeding it. It means that it is the cumulative frequency lower than the median class. So 42 is the value of F. We already have here the value of I and the value of N. All we're left to do is to substitute those to our formula. Okay, so once again, the value of L, or our exact lower limit or lower boundary, is 79.5. The value of n over 2, or our median class, is 50. And then the cumulative frequency is 42. The frequency of the median class is 25. And the interval is 5. Okay, substituting all of those values, we will have 79.5 plus the quantity 50 minus 42 divided by 25. Multiply that by 5. Simplifying further, we have 79.5 plus 8 over 20, the quantity 8 over 25 times 5. And then we can multiply these two, or we can use cancellation. In this case, we have multiplied 8 and 5. That's why we have written there 79.5 plus 40 over 25. Using Gemdas rule or MDAS rule, we simplify 40 over 25, or 40 divided by 25. The result is 1.6. We add 1.6 and 79.5 to get the value of the median, which is 81.1. So that is the median for example number 3. We follow the same steps as we answer example 4. For example number 4, we will calculate the median for the following data. We have here how many intervals? 1, 2, 3, 4, and 5. The value of I is already given, which is 5. And then the value of N is 50. First, we have to determine the median class, again by dividing the total number of observations into 2. The median class is N over 2, so 50 divided by 2 is equal to 25. After that, we continued with step 2. Again, we get the exact lower limit or lower boundary by getting the average of the lower limit and upper limit of the next interval. And the result is 89.5 for the first interval, followed by 84.5, and then 79.5, 74.5, and 69.5. Step 3, we get the cumulative frequency. Again, we start with the value of n, which is 50. So 50, and then from that we subtract the frequencies. So 50 minus 7 is equal to 43. 43 minus 13 is 30. 30 minus 16 is 14. And 14 minus 8 is 6. Again, the cumulative frequency and the frequency for the last interval should be the same. And for step 4, we locate the median class in which the median lies and identify the frequency and lower limit. We have solved the value of median class a while ago, and the value is 25. Okay, so 25 belongs here in this interval. Okay, so we identify, we get the value of 16 and write f, the value of f or small f is 16, and then our exact lower limit or lower boundary is 79.5. And then step 5, we get the cumulative frequency that is lower than the median class, and that is 14. So the value of f is 14. Step 6, we have to substitute all of those values in our formula. For step 6, here is our formula again, and these are the results that we have obtained from steps 1 to 5. The value of L is 79.5, and over 2, or median class, is 25. The cumulative frequency is 14, F is 16, and the interval is 5. Substituting all of those values, we will have 79.5 plus the quantity 25 minus 14 divided by 16 times 5. Simplifying the group, the numbers inside the parentheses, we will have 11 over 16, and then we multiply that by 5. The result we will add to 79.5. So we have 79.5 plus 55 over 16. Once again, we divide this first. 55 divided by 16 is 3.44. We add that to 79.5, and we will obtain the median, which is 82.94. That is the value of the median for example number 4. The next measure of central tendency is the mode. If in the ungrouped data, we simply identify the mode based on the number which occurred the most. So for group data, it is also easy to solve for the mode. We only have 2 steps. For step 1, we locate the modal class by determining the highest frequency in the distribution. So again, we are considering the number or the modal class or the interval with the highest frequency. And then for step 2, we determine the value needed to compute for the mode and substitute it to the formula. Here is our formula. So we have mode is equal to L subscript MO. So that is the symbol or notation for the exact lower limit of the modal class, plus the quantity d sub 1. D sub 1 is the difference between the frequency of the modal class and that of the frequency below the modal class, over d sub 1 plus d sub 2. D sub 2, on the other hand, is the difference of the frequency of the modal class and that of the frequency above the modal class. And then we have the value of I, or the size of the class interval. Okay, here is our example. It says there, consider the distribution of the weekly wages of the factory workers in the NCOV face mask factory. Compute for the mode. We follow our steps. For step 1, we locate the modal class by determining the highest frequency in the distribution. Looking at our table, the frequency or the interval with the highest frequency is this, 2320 to 2339, and the frequency is 31. That is then our modal class. After that, we get the value of d sub 1. D sub 1, it says there the difference between the frequency of the modal class and that of the frequency below the modal class. The frequency below it is 24. When we subtract, 31 minus 24 is equal to 7. That is the value of d sub 1. And then d sub 2, the difference of the frequency of the modal class and that of the frequency above it, means that we will consider 12. 31 minus 12 is equal to 19. That is the value of our, or that is the value of d sub 2. We have our necessary data, the value of d sub 1, d sub 2, n, and then I. Substitute all of those values to our formula. Oh, by the way, we have here we need the value of the exact lower limit of our modal class. How did we obtain 2319.5? We obtained that by getting the average of these two numbers, the lower limit and then the upper limit of the interval below the modal class. Okay, we substitute all of those values. So we have mode is equal to 2319.5 plus the quantity 7 over 7 plus 19, but multiplied by 20. First, we simplify these groupings. So we have 2319.5 plus the quantity 7 over 26 times 20. Next, we multiply this. So we have 2319.5 plus 140 over 26. Simplifying this, the result is 5.38. We add it to 2319.5, and the sum is 2324.88. That is the value of the mode for example number 5. Well, that ends our lesson for measures of central tendency of ungrouped data. Our next video will be on measures of variability, both in group and ungrouped data. Until then, please watch our next video. Goodbye. once again, dear students. Today we are going to continue with our lesson for the fourth quarter, which is on the measures of variability, group and ungrouped data. First, let us define the measure or measure of variability. The measure of variability refers to the spread of values about the mean. These measures help visualize the shape of the dataset together with the extreme values. Smaller dispersion of scores arising from the comparison often indicates more consistency and more reliability. On the other hand, if it has a greater dispersion, then it means that the data is less consistent or less reliable. The most commonly used measure of central of variability are the range, the average deviation, the standard deviation, and the variance. So those are four of the topics or subtopics that we are going to discuss today as we solve examples. Let us start with solving the range. Before we start, let's have a quick game. Can you find the difference between the highest and lowest number in the given set of numbers that I am going to show you? So solve as quickly as you can. For letter A, what is the difference between the highest and the lowest number? Okay, the highest number here is 95. Am I right? And the lowest number is 78. When we subtract those two, 95 minus 78 is equal to 17. Okay, so the answer to letter A is 17. Next, B. Can you solve for the difference of the highest and the lowest number? All right, our highest number is 23, or no, it is 25, and the lowest number is 14. Subtracting those two, the result is 11. Next, letter C. 23, 45, 60, 20, 25, 44, and 38. The highest number is 60, and the lowest number is 20. So subtracting those two, 60 minus 20 is equal to 40. All right. Next, we have this set of numbers. What is the difference between the highest and lowest? The answer is 8. Am I right? Because the highest number is 9 and the lowest number is 1. And 9 minus 1 is equal to 8. That is the answer to letter D. And for the last one, what is the difference? Our highest number is 165 and the lowest number is 113. Subtracting those two, the result is 52. From this activity, we have already done the first measure of variability. Okay, we have already solved for the measure of variability for each of the set of the data. And what is that? I'm referring to range. Okay. Again, range. What we have solved is actually the range of the set of data. It says there, the range is the simplest measure of variability. It is the difference between the largest value and the lowest value. It is the measure which requires the simplest computation. So simply subtract, identify the highest and the lowest, and then subtract them. And that is the range. So here is our formula. The range is equal to the largest value minus the smallest value. We have here an example. For example 1, the grades in mathematics of 10 students of 2 sections in ECN VHS were as follows. Here are the grades for section Einstein and the grades for section Archimedes. And how do we get the range for Einstein or section Einstein? We subtract the highest, which is 95, and then the lowest, which is 88. The result is 7. For section Archimedes, the highest is a 95. Oh no, it is 98, and the lowest is 87. Subtracting those two, 98 minus 87 is equal to 11. From that, what can we infer? Well, here is the clearer solution, but we have the same answer. Again, the range for section Einstein is 7, and the range of the grades of section Archimedes is 11. We can then say that the scores of the Archimedes section has greater variation or more dispersed than that of the score of Einstein, since the range is greater than that of the other one. Okay, here is another example. The following are the daily cases of COVID-19 in 2 successive weeks. For week 1, here is the set of data. Week 2, here is the set of data. We have to compare the range between those 2 weeks. For week 1, the highest number of cases is 210 and the lowest is 98. We subtract those two, so 210 minus 98 is equal to 112. That is the range for week 1. How about for week 2? The highest number of cases is 264 and the lowest is 122. When we subtract those two, the result is 142. From that, we can identify which week has a greater dispersion. Okay, and for our analysis, since week 2 has a greater range, so we can say, or this indicates that the number of cases of COVID-19 on week 2 is more dispersed or scattered compared to that of week 1 because it has a greater value of range. And we have here more examples, but the answer is already given. Okay, for number 1, 25 is the highest number or largest number and 1 is the lowest number. And 25 minus 1 is equal to 24. For number 2, the largest number is 92 and the lowest number is 75. Subtracting those two, 92 minus 75 is equal to 17. Number 3, the largest decimal is 2.5 and the lowest is 1.0. Subtracting those two, the difference is 1.5, so that is the range of the data in number 3. If that is for ungrouped data, here is how we solve for the measure or the range of group data. Our formula is simply this. Range is equal to the highest class boundary minus the lowest class boundary. Okay. So in this case, we have here an example. Our upper limit, the upper limit of the highest interval is 50 and the lower limit of our the lower limit of our lowest interval is 16. How do we get the exact boundaries? Okay, for upper limit, we get its average and the lower limit of the next one, but there's none. That's why we simply write there 50.5. Okay, so the exact boundary of this is 50.5. On the other hand, the exact lower boundary is 15.5. Alright, so we have those values and we substitute it to our formula. Our formula is this: the highest class boundary plus the lowest class boundary. Our highest class boundary was 50.5 and then the lowest is 15.5. So when we subtract those two, the result is 35, and that is the range of this group data. Isn't it easy? Yes, it's very easy. Now, for average or mean deviation, this is our second measure of variability. First, let us deal with ungrouped data, or the mean deviation of an ungrouped data. So we have here a procedure. For step 1, we first find the mean of all the cases, and then step 2, find the absolute difference between each score and the mean. And then step 3, we find the sum of the differences and divide it by the number of scores or cases. Let's go over those steps as we answer some examples. By the way, here is our formula. So MD, remember we are using capital D, M, and then capital D, because if we are using MD, wherein we have a lower case D, that is for median. Okay, but for M and then capital D, capital M, and capital D, that is for mean deviation. Again, this is for median. Okay, the formula is MD is equal to the sum of the absolute value of the values of X minus the mean. And then divide that by the value of N, or the total number of cases. Okay, let's have an example. Find average or mean deviation on the following heights of students in centimeters. First, let us solve for the mean. How do we do that? Since it is an ungrouped data, we add all of the values and then divide it by the total number of cases. So 125 plus 122 plus 115 plus 127 plus 120 plus 117 divided by 6. Divide those two. The total of the numerator is 726 divided by 6. The result is 121. That is only the mean, that is not yet the mean deviation. We use that to accomplish step 2. For step 2, we find the absolute difference between each score and the mean. Since we know that the mean is 122, am I right? Oh no, it is 121. It's already stated here. Okay, we simply subtract those and then get its absolute value. For the first pair, 125 minus 121 is 4. 122 minus 121 is 1. 115 minus 121 is negative 6. But we will get its absolute value. That's why what is written there is positive 6. 127 minus 121 is 6. 120 minus 121 is supposed to be negative 1, but we will get the absolute value. That's why we have there positive 1. 117 minus 121 is negative 4. Its absolute value is positive 4. And then the next thing that we will do is to add all of the values of the difference between the value of x and the mean. Okay, 4 plus 1 plus 6 plus 6 plus 1 plus 4 is equal to 22. That is for step 2. Next, for step 3, we find the sum of the difference and divide it by the number of scores or cases. We simply substitute the values that we have obtained in step 1 and 2 to our formula. Okay, so the sum of the difference between the values of x and the mean is 22, right? And the value of n is 6. We divide those two. 22 divided by 6 is equal to 3.67. That is the mean deviation. That is the mean deviation for this example. Okay, this time we discuss how to solve for the mean deviation of a group data. Here is the procedure. For step 1, we determine the class mark. Again, we use the symbol capital X for it, and find the product of the frequency and the class mark under column Fx. So it's like solving for what was that? Mean, right, of group data. Afterwards, get the summation of F times X. Okay. Then step 2, solve for the mean using the data obtained in step 1. Step 3, find the absolute difference between the class mark of each interval and the mean. For step 4, we multiply the frequency by the answer that we've got in step 3 for the column F times class mark minus mean. And then afterwards, get the summation of F times X minus the mean. Okay, and step 5, solve for the average or mean deviation by using the formula. Okay, so here is our formula in solving for the mean deviation of group data. We have there mean deviation is equal to the sum of all frequencies times the absolute value of the difference between the class mark and the mean. Divide that by n, and that is the mean deviation. Let's have this example. Find the average or mean deviation of the results of the survey made by students regarding the number of sleep-in hours in a day of the grade 7 students of Easy and VHS. Okay, so here is our data. Follow our steps. Alright, so we have here our expanded table. We have here the given value of x and then its frequencies. Okay, so our intervals are this: 13 to 15, 10 to 12, 7 to 9, 4 to 6, and then here are the frequencies. From those frequencies, we can add them all to get the value of n. 5 plus 25 is 30, plus 8 plus 2, that is equal to 40. So the value of our n is 40. Next, we solve for the value of x, or the class mark. Again, we do that by getting the midpoint of the lower limit and the upper limit. Okay, so 13 plus 15 is equal to 28, divided by 2 is equal to 14, or simply determine the number between 13 and 15, and that is 14. Between 10 and 12 is 11. That's why the class mark for this interval is 11. For 7 and 9, the class mark is 8. And then 4 to 6, the class mark is 5. After that, we complete our next column, the product of F times the class mark. So 5 times 14 is 70. 25 times 11 is 275. 8 times 8 is 64. 2 times 5 is 10. And then we get the total of the product of the frequency and the class marks. The result is 419. After that, we solve for the mean. Our mean is obtained by dividing this 2. 419 divided by 40. When we divide those two, the result is 10.475, or 10 and 475 thousandths. Okay, given the value of mean, we get the value of class mark minus the mean, and then it has an absolute value. That's why we get the positive equivalent of those differences. Okay, starting from this pair, so we have 14 minus 10.475, which is our mean. So the result is 3.525. Next, 11 minus 10.475 is 0.525. Next, 8 minus 10.475 is 2.475. And then lastly, 5 minus 10.475 is equal to negative 5.475, but again, we will get the positive equivalent, or the absolute value. That's why we will write 5.475. Next, we multiply our frequency by the absolute value of the difference between the class mark and the value of the mean. Okay. Or we simply multiply these two pairs. 5 times 3.525 is 17.625. 25 times 0.525 is equal to 13.125. 8 times 2.475 is 19.8. And 8, or what's that? 2 times 5.475 is equal to 10.95. We add all of those to obtain this, and the sum is 61.5. By completing this table, we can obtain the necessary information, which we will substitute to our formula. Here is a clearer view of the solution that we have done a while ago. Okay, this is a cleaner one, but we obtain the same results. The value of n is 40. The sum of the product of the frequency and the class mark is 419, and then this is, or the sum of the product of the frequency and the difference between the class mark and the mean is 61.5. We can substitute all of this to our formula. Our formula is this, and we have already obtained this value, or the value of this, and it is 61.5. So our numerator is 61.5, and then the value of n is 40. When we divide those two, the quotient is 1.538, or 1 and 538 thousandths. That is, we are down to our third and fourth measure of variance or variability, which is the standard deviation and the variance. Let us first deal with examples in solving for the standard deviation and variance of an ungrouped data. Here, there are steps that we also need to follow. For step 1, we find the mean. Step 2, subtract the mean from each cases, x minus the mean, then get the square of their difference. Step 3, get the summation of the squared difference. And then step 4, solve for the standard deviation and variance. And we have here our formula. ST, or standard deviation, is equal to the square root, square root of the sum of the difference between x and the mean, the quantity squared, over n. For us to get the variance, we simply square the value of the standard deviation, so that they are actually interrelated. Let's have an example. In a survey made by DOH on the pandemic COVID-19, the following are the daily number of cases of the infectious virus. Find the standard deviation and the variance of the data gathered. For step 1, we again find the mean. We do that by adding all of the scores. So scores, or the total number of cases per day, 212 plus 185 plus 230 plus 310 plus 288 is equal to 1225. Divide that by 5, the result is 245. So that is just the mean. We need the mean to accomplish the next steps. Okay, step 2 and step 3 are already here. For step 2, we are going to subtract the value of x and the value of the mean. We have solved the mean a while ago, and the value was, what was the value of the mean once again? It is 245. Okay, that's why for the first one, 212 minus 245 is equal to negative 33. Next, 185 minus 245 is equal to negative 60. 230 minus 245 is negative 15. 310 minus 65 is 65. 310 minus 245 is equal to 65. 288 minus 245 is equal to 43. Then we square those results. Negative 33, the quantity squared, is positive 1089. Negative 60, the quantity squared, is positive 3600. Negative 15, the quantity squared, is 225. 65 squared is 4225. And 43 squared is equal to 1849. We get the sum of all of those, and the result is 10,988. We have already obtained the necessary data. We simply substitute it to our formula. It is already substituted in our given. So we have a standard deviation is equal to the absolute value of the sum of the square of the difference of the values of x and the mean, which is 10,988, divided by 5, or the value of n. We simplify first the number inside the radical sign. 10,988 is equal to 2197.6. And when we get the square root of that, the result is 46.879, or 46 and 879 thousandths. Okay, so for the variance, we simply square this value. So 46.879 times 2 is 2,197. Or if you will go back before getting the square root, you can already say that the value inside that radical sign is the variance. Okay, variance. Okay, I will no longer write it. That is the variance. Okay, next. So steps in solving for the standard deviation and variance of group data. So this time we are going to solve for an example that involves a group data. We also have a series of steps. So first step is for us to make a table. Find the class mark or midpoint of each class mark, then get a square of the class mark. For step 2, we multiply the frequency by the square of the class mark or midpoint for each class. And then for step 3, we multiply the frequency by the class mark or midpoint for each class. And then step 4, find the summation of the product of the frequency and the square of the class mark. So the sum of the product of the frequency and the square of the class mark. Here is the symbol. Okay, and here is the symbol for the other one. And of course, for the fifth one, we solve for the standard deviation using this formula. Standard deviation is equal to the square root of n times the sum of the product of f and x squared minus the sum of the product of f times x, the quantity squared, over n. When we square that, the result is the variance. Okay, here is the example. We find the standard deviation and variance of the following data. How do we do that? We follow the steps. So in following the steps, we will obtain all of these values. Okay, so when you answer the activities, simply construct a table, x for the class mark, and then x squared for the square of the class mark, f times x squared, and then f times the value of the class mark. Okay, first, for us to get again the class mark, we simply add our lower limit and upper limit for each interval. Or you may count. So we have 16, 17, 18, 19, 20. The number in the middle is 18. So the class mark for this interval is 18. Next, for the interval 11 to 15, we get the class mark, which is 13. For the next one, it is 8. And then the next one is 3. We square each of those to get to complete the fourth column. So 18 squared is equal to 324, 13 squared is equal to 169, 8 squared is equal to 64, 3 squared is equal to 9. Then we multiply those two, the frequency and the value of x squared. So 2 times 324 is equal to, 8 times 324 is equal to 2,592. 5 times 169 is 845. 15 times 64 is 960. And 2 times 9 is equal to 18. Okay. And lastly, for the last column, we simply multiply our frequency and the class mark. So 8 times 18 is 144. 5 times 13 is 65. 15 times 8 is 120, and 2 times 3 is 6. Add all of those to get 335. So we have the value of the sum of the product of f times the class mark, and then the sum of the product of the frequency and x squared. Okay, here is again a clearer answer, okay, or solution to our example. But again, we have obtained the same result. We substitute the values that we have obtained in our formula. So the value of n is again 30. The value of the sum of f times x squared is 4,415. And then the sum of f times x is 335. We square that. And then we divide the result by 30. Simplifying further, 132,450. Wait, 132,450 minus 112,225 is equal to 20,225. And then we divide it by 30. When we divide those two, we will obtain 674.167. And we can already write that as the variance. But when we get the square root, the result is 25.965. That is our standard deviation. So again, when we square that result, we get the value of the variance. So here are the values that we have obtained: 25.965 for the standard deviation, and for the variance, the result is 674.167. That is it for our lesson for today. Thank you so much for listening. Goodbye.